These are heavy topics we're going to have to wrestle with as this tech keeps advancing. All right, super exciting stuff coming out of Google's DeepMind. So they've come up with a new way to train AI models that's not only faster, but also way more efficient. This method is called JEST, which stands for Joint Example Selection, and trust me, it's pretty revolutionary, so let's talk about it. All right, so if you know anything about AI, you know that training these models usually takes a ton of time and a lot of computing power. It's like trying to teach a child every subject in school one by one, and it's super energy intensive. For example, systems like ChatGPT guzzle a lot of power and water to keep those massive data centers cool. There are even comparisons to the energy demands of Bitcoin mining. Yeah, it's that intense. But here's where JEST comes into play. The researchers at DeepMind have found a way to make this whole process way more efficient. How efficient? Like up to 13 times fewer iterations and 10 times less computation. That's a game changer for both speed and energy consumption. So how does JEST work? Instead of picking individual pieces of data to train on, which is what's usually done, JEST looks at groups or batches of data and picks the best ones that work well together. Think of trying to learn multiple languages. Instead of learning English, then German, then Norwegian separately, you might find it more effective to study them in a way where what you learn in one language helps you understand the others. That's essentially what JEST does, but with data. Here's a bit more on the technical side, but I'll keep it simple. The method JEST uses is called multimodal contrastive learning. This means it looks at different types of data, like images and text, together, and it identifies dependencies between them. This approach significantly speeds up the learning process because the AI can learn from these well-matched data batches much more efficiently. What makes JEST even cooler is that it starts with something called a pre-trained reference model. This model helps steer the AI towards the high-quality, well-curated data, making the training even more efficient. Now, the study showed that using JEST, they could achieve the same performance as traditional methods with up to 13 times fewer iterations. Also, it requires 10 times less computational power. So, in terms of energy consumption, that's a massive reduction, which is great news for the environment. Now, the JEST research comes not a moment too soon, as the tech industry and world governments are beginning discussions on artificial intelligence's extreme power demands. To give you an idea, AI workloads consumed about 4.3 gigawatts in 2023, which is almost equivalent to the annual power consumption of the entire nation of Cyprus. And this trend is only going up. A single ChatGPT request currently costs 10 times more in power than a Google search. It's estimated that AI might take up a quarter of the United States power grid by 2030. Therefore, any method like JEST that can drastically cut down on the power required for training AI models is incredibly significant, potentially easing the environmental impact and the financial costs associated with AI advancements.